I almost don't want to use my voice because my throat is just now permanently blocked with something. It's just God knows what. It's that permanent illness, you know. You know the feeling when you have a permanent illness. So, a few different people have sort of described it to me, but that's definitely what I'm feeling like I have now. Let's move the mic down slightly. One sec. Never mind. Yep, welcome to Sesh 3, Raft, Rafto the Third. Yesterday went so hard, I just completely got lost into, well, not even that much in the content, but just mentally, like, being able to, mess my lip up a bit. Being able to, explain what was going on and everything, I just got a bit confused and, well, exhausted really, so this sesh will pick it up where we left off. I'll do a very quick summary before launching into what will be I think, the thing that I set out to do yesterday, which was start part 2A. Well, yesterday I didn't know what Raft was, now I do. Not, I said I understood most of it, but definitely that one session is not going to be enough to reliably be able to command the material to, remember. Um, what's what. Um, so yeah, I mean, I'm not going to consolidate it again. I'm just going to jump in to do part 2A. Partly because, of course, part 2A is quite small. Well, it had 14 hints, but nonetheless, it's implementing a sub-system of the whole Raft system, and this is a very complex system indeed, so we'll definitely try to start small and not try to do the whole thing at once. If you guys remember, I mean, I made some scrap notes to try to describe just what the hell is going on here. So I'll just expand them all out. Yep. We have RPC specifications, the specifications for the remote procedure calls, the interactions between the computers, and the one that is not written down here is the send to apply channel in order to do the application, because that's not implemented as an RPC in terms of this lab, but is instead implemented as a Go channel that you send the result to. Apply channel, if you remember, apply channel. So, yeah, I'm not going to write that down because they don't themselves describe it as an RPC, but there is also... Okay, do you know what, I'll put down apply ch here to describe that, but I'm not gonna elaborate on that for the time being. We had a couple of very broad ideas for what the concept of Raft is. Leader updates followers on log progress, and re-elections if a follower doesn't receive append entries from leader. And also if it hasn't issued a vote recently, a successful vote. Sorry, a true vote. A vote for. If it hasn't issued one of those, and also the leader stopped replying, then it would trigger a re-election. That's what's being timed out on. A pile of state variables, the ones for general and the ones for leader. So these 7. Have an idea of what all of them do. And then just, everything is flushing data, everything is synchronizing based on term. Followers can become candidates given a timeout. So let's call that candidacy timeout. And then all the things the candidate does, well, the candidate really just starts elections and is allowed to be interrupted during an election. And leader, well, the leader is the complicated bit, and this doesn't describe everything the leader does. There are bits of the figure 2 summary thing that has all the information that we'll probably need in it. There are bits of that I haven't actually gone through properly yet. Well, I went through all of it once, but some of it I haven't been through twice. And you have to go through all of it twice. There's no other way. So this isn't everything. That's my point. But it sort of includes most of the useful stuff. You know, leader sending heartbeats to say that it's still alive, handling client requests, keeping followers updated, and actually registering replicated log writes, i.e., committing to log. Yeah, I should put that down. You know, you can add to the log without committing, but you can also commit to the log. So there are two separate log states. One is just write to log, and the other is commit to log. Face is okay. It's random stuff. Yeah, so let's call it for what it is. Commit to log. Followers also commit to log, I think, but they commit to log in a different way, which hasn't actually been explained yet. But despite the fact that I haven't summarized absolutely everything, there are bits of Raft that I still haven't been over properly. I'm not going to go over the rest of it now because I don't want to put myself back in that mindset. Instead, I'm going to break off a small part of it and understand it by implementing it. And that's what I mean by why I'm going to immediately just go into part 2A. I'm not going to read over the bits and pieces that I didn't read over last time. What I mean, by the way, when I say what did I miss last time is, you know, we have figure 2, if you remember. Windows is being difficult. You know, there's a very, very narrow pixel tolerance for when you can resize a window in Windows. It's hilariously narrow. Just a mistake that one of their engineers made. So yeah, we had rules for servers. That's what I have been over, and I know what all the state variables do. But the RPCs, append entries and request votes, they have some receiver implementation details that actually do themselves contribute rules that haven't been logged in the rules list. So, you know, stuff like incrementing the leader, the commit index, right? So that's a receiver of an append entries, i.e. the follower incrementing commit index. That's something we haven't covered yet. But there's information about how to do that here. And likewise, there's probably a bit of stuff here about how voting is done, but I think that's mostly been covered. So, okay, maybe the only thing that's not been covered is the follower, how the follower handles committing to the log. Okay, so let me just also just summarize what should be done. You know, the processes. Let's make like a phases node. So there is writing to log, committing to log, and applying to service. So, you know, and this is something that happens to all the data. These are data phases, as in it's something that happens to the data. Right, you know, every piece of data gets written to the log, committed to the log on leader or follower, and then applied to the service. All of them, leader and follower, all do all of these things. Right, there's no single point of failure in any of this process. And the election phase is separate. I'm not gonna bother re-describing that. But those three steps are basically independent of each other. They happen concurrently to each other, implemented separately. So it is just worth making a mental note of that. You know, when we try to distinguish what's what. So commit index is all about tracking committing to log. Last applied is all about tracking applying to service. And writing to log is something that just continually keeps happening as soon as possible, so there's no index tracking that. It's just the commitment is if there have been a successful replication, if there's been successful replication to the majority of the cluster, i.e. most of the servers have done a write, then we do a commit. Right, so that's the whole replication redundancy failsafe method that Raft uses to process data. Yeah, that's pretty much it. Current term and voted for are all about the election phase. Well, voted for is about the election phase, but current term is always there, and it just tracks when it's trying to figure out when the leader failed, so that a new election can be triggered. And these two variables are the leader paying attention to the followers, what they're up to, in terms of next log entry to send and latest log entry the peer has. Still not completely clear on the difference functionally between these two, but it's all about tracking how up to date the peers are when it comes to writing and committing. Which of those? Both of them probably. That could even be the difference. It's not too important. But yeah, that's my in the beginning there was a summary. What's happening now? Like I said, I am, streaming is all working very nicely. We are live. What happens now is I'm going to try part 2A. I'm going to try to sketch it out. I already actually have a notes on 2A, but yeah, I sort of jumped the gun starting this yesterday. I'm probably going to have to go back over all this, cover all of it, and then turn it into a skeletal outline. And yeah, should be happy about that. Getting slightly distracted, some windows moving just outside. Mum's been shuffling about again. So that's a good time to just take a quick break, I guess, anyway. So like I said, we know what we're starting with, and I'm going to do like a checkpoint there. Yep. Cool. Let me just scroll to all the stuff, set this all up. Relax a little bit. Oh yeah, one thing I should remember to do is to just do a quick commit to say this is where we got to. I did a few edits just now, but for the most part, this is where we got to after understanding Raft. Quite a lot of these are just moving things into an old folder, so these text files that got deleted and then those are just moved. But I've also added figure 2 and a couple of text notes that are relevant to us. So that's the only stuff that's changed. If you see, it's all text files and PDFs. I've not actually done any coding at all. Yesterday I barely touched Visual Studio Code. It's quite ridiculous, but yeah, should be okay to do that. So a quick commit, send all of that up. Yeah, so I'll just chill for another minute while my ambience settles down a bit. Yeah, the toilet is literally less than a meter, well, less than 2 meters away from me. It's within a 2 meter radius of me, so I'm definitely constantly notice the toilet if someone's using it. It can be quite distracting when working. Well, particularly if you have the window open because of all the to get all the air inside to keep the laptop nice and chilled out. It's still pretty quiet, 80 degrees. But wow, yeah, it's a nice day. I can put my hand outside the window. go for a walk after all this is done. You know, keep chill. As I'm waiting for my mum to take a shit. Wonder if she can hear me through the open windows. So you have a couple of open windows, so it's literally like almost like talking to someone across a 2 meter gap. God, it is actually really warm outside. I could just have my hand outside and it'll just warm up slowly. So yeah, the walk will be the one after we're done with this session. Next session is going to be again 9 p.m. tomorrow. So I've just given myself a break again. I intended this session to be a kind of consolidation. Consolidate by doing, you know, jump into 2A and hope that it works out. But then schedule another one in a day and a half. Chiefly to give myself a break so I can manage all of the admin in my life, a few other things that I should be doing at the same time as this project. And so I'm trying to keep it more balanced. MapReduce, I was going a bit too fast. This is more, I'm trying to average once a day, but it's good to sort of bunch up a couple of sessions sequentially, so that you can keep your mind focused and then take a break, so that you can sort out all the other stuff that's going on. So that's gonna happen. 9 p.m. Sesh 4. This is taking a while, I'm sorry. Alright, I got a chat message. Yeah, I do wonder if Cable Guy DK, if you know that I'm using this trash Motorola G3 as my webcam at the moment. I'm not a fan of Motorola as a result of that. Maybe back in the day, yeah, the sexy V3 out. That used to cost, I mean, do you remember the times when that phone, the Motorola V3 cost like 280 quid? Absolutely ridiculous. Yeah, in Go you have to import FMT and write print lun like an old school C style language, even though Go is really recent. I think it was released in 2005. It's a bit of shit like that. Console log hello motor. What do you think hello would even return? I don't know. Probably just the identity function. Yeah, again, sorry about the delay. I'm just waiting for the toilet basically to stop running. I just find that so distracting when it's 2 meters away from me. It's 2 meters away from me, but like the straight line path from me to the toilet actually leaves my house because there's a corner, and so here where I can stick my hand out of the window. Not to waste too much time, but you can see the toilet there. You can see the window to the toilet. If I just chuck this bottle out, if I'm moving the entire camera stand, I don't know why. Maybe I should have just moved the phone. That would have been less stupid. But yeah, that's the toilet. Cool. Shit. Yeah, definitely don't move the entire camera stand next time. I don't know why I did that. Whoa. Okay. Yep, that's all good. True. Yeah, pretty much. So it just logs the word true. Fair enough, fair enough. Okay. Toilet is finally silent. Toilet is finally silent, so I'm gonna do what? Well, I'm gonna do a break, as in do a partition, where I write in the chat, okay, I'm moving on and doing the next section of the stream. I don't even know how to write that down. I'm just going to say like, yep, we'll now read and sketch 2A in the project. MIT, Distributed Systems coursework. Project 2, Raft, Rafto, Part 2A, here it is. So this website, if you haven't seen it, 6.824 Distributed Systems. Cool. Well, this is the most active my chat has ever been. This is struggling. I hope I don't get too distracted. Okay, let's go. No worries. Chat all you like. I will deal with it. Yeah, part 2A. Part 2A. Raft is, I mean, like I said yesterday, I spent 3.5 hours just trying to figure out the algorithm in general, pretty much all the different parts of it. And I wrote it down in this sketch document. Lots of stuff. If you can see all of the general ideas of what's going on, you know, flushing the data to the service that's using Raft as its underlying algorithm, synchronization of voting terms, when does the follower call an election, all this stuff. I'm not going to go over it again. But what we're doing with 2A is focusing on a particular part of that, trying to start with something small that is hopefully easy enough to sketch out and implement without getting too confused over the rest of it. So yeah, let's give it a shot. Implement leader election and heartbeats, that's what we are doing. So not to worry about the data, not to worry about committing data, the commit index, the leader knowing what the followers are up to in terms of their logs. We don't care about logs at all. Instead, we're just focusing on heartbeats, which is the append entries, RPCs, with no log entries that the leader is constantly sending to followers, and the followers waiting for heartbeats. And if they don't receive heartbeats, they call a leader election to get a new leader, because not receiving heartbeats is the idea of the leader's probably died. There was no heartbeat. He's dead, Jim. That's yeah. The other thing about leader election, the timeouts, so the relevant bits of the sketch that I've written down, the timeout that leads to the election happening is not just receiving append entries, which is my general term for a heartbeat. A heartbeat is, I'm calling a heartbeat an empty append entry, but append entry is actually also used for sending data. Either way, it's a message from the leader to the followers. So that's why it counts as a thing that keeps the leader alive, if these messages are being received. This is from the follower's point of view. You know, if there is a timeout on that, or grant vote, which is to say, it's been a long time since the follower granted the vote to anyone, which is implying kind of the leader has been active long enough. So that times out pretty fast. But then when the leader stops being active, we time out on receiving append entries from the leader. And so it becomes a candidate starts an election, and then we implement the election, okay? So that's basically the system there, and we determine what's a leader, what's a follower, and of course when something gets elected a leader, it starts by sending heartbeats again. So those two things are in and of themselves kind of cyclical. So it's a kind of subsystem without even paying attention to how the data works. It's a pretty reasonable subsystem to try. Yeah, this You can hope, but if you've not implemented anything, it will give you something along the lines of the file is not even found or something. Well, okay, Raft actually doesn't use files. It doesn't use files at all, but all the same, we'll get an error along those lines. I can show you if you like. init.sh. Yeah, I have to change directory into my distributed systems folder via the symlink. This is the Linux emulator within Windows, Ubuntu. It's not even Bash for Windows, it's Ubuntu. So we set the path by doing that and then run the test. Go test run 2A, which is the project we're doing, and it's just gonna give us some testicles. You know, that's what we're gonna get out of this. Election, you can hope. Having written absolutely zero code. Expected one leader, got no leader. Election after network failure, same thing. So yeah, one could hope that one needn't do any work, but alas. Yeah, so indeed, that is fair enough. Yeah, it's something I've spoken about before, I guess. A lot of software developers will always ritualistically do the test first. And some of them go as far as to say like, oh, let's implement like some piece of code that's clearly irrelevant just so we can pass the most basic test. But I don't tend to go for that. I'm happy to try to crack out an attempt and then test it. That works fine for me. Although, yeah, I did test that the tests were working. To be fair, I did do that. Set up the environment and everything. The goal for Part 2A is for a single leader to be elected, for the leader to remain the leader if there are no failures, and for a new leader to take over if the old leader fails, or if packets to from the old leader are lost. So I don't want to read too much into this, for example, because it's kind of clearer what that means from the framework that was given, the sketch here. No, sorry, not this sketch. The outline of Raft itself that I did yesterday. It's kind of clearer. It's clearer from that what it means for the leader to die. What it means for the leader to die, and that is the whole cycle of election timeouts, basically. So I'm not gonna get too hung up on that. But yeah, these hints like 14 fuck off hints. I started reading through these yesterday, and I sort of summarized 5 of them, but like then I decided I didn't know anything. I didn't know shit about Raft, and I had to go over everything again. So I'm gonna have to, I guess, sort of I'm gonna just flick through my summary and hope that that stuff actually makes sense. Yeah, I will just quickly blow my nose again. One sec. Oops. Where is Figure 2 paper? I'll just send you a link to that. No problem. The paper itself, it's Figure 2 within the paper, and the paper is here. Extended Raft paper. Which, why not just chuck it in the chat? Brackets Figure 2. Chill. Okay, just blow my. Still, no problem. Still trying to survive my hay fever / persistent colds. You know, a cold is about as persistent as as my Raft server's going to be once I've implemented it, yeah. Heathrow Airport or terrorism? Pick one. Yeah, living in West London. Um, okay, where was I? Trying to flick through what's going on here. Or air show in Farnborough, maybe. Farnborough's only. It's not. It's in Surrey, but it's not that far away from here. I mean, air wise. Um, Farnborough Air Show. Yep, we're implementing the leader election heartbeats. Those are cyclical, like I kind of described. This is what a heartbeat is. Leader assertion, single leader is elected, new leader takes over if old leader fails, or this. This I said is not too important to internalize. Single leader being elected is quite important to do that correctly because, well, okay, yeah, obviously the test tests for that. But not only that, but there's a logical assertion that drops out of, which is that every election round, yeah, the all the followers have their own idea of which election round they're in, even if different election rounds are actually don't correspond to the same candidate because there was a network error and they don't all communicate. But nonetheless, all of them are logging what the election round is, and every time there's a new election round, they clear their who did I vote for variable and vote for the first applicable person. Applicable meaning is up to date from the perspective of the follower, and yeah, that's it. Vote for and called an election. Sorry, that's not completely clear, but it should become clearer as we go on. And therefore, per election term, from the perspective of a follower, but all the election terms are absolutely numbered, and they get updated whenever the things can synchronize. Literally every RPC in Raft synchronizes election terms in the sense of what a server and another server think is the current election term. Those get synchronized with every RPC as a kind of side effect of what the RPC was supposed to be doing, like sending data, calling an election, all that stuff. So it's important. This is a really important assertion. Well, not an assertion because it's not an assertion because it can go wrong if things get detached. But this sentence here, general doings, meaning something that every server is doing all of the time, is synchronizing terms. If my term is old, I should be the follower, and also I update my term to the term that I just was told is a newer term. So, RPCs are like a handshake. I said server 1 sends RPC to server 2, receives a response, and in both cases server 1 sends over its term to server 2 and server 2 does the same, and whichever one of those is newer updates the other one, and if one of them had an old term, it sets itself to follow it. It uses that as a kind of reason to think it's not the leader. If it used to think it's the leader, if things have moved on, that means there was probably a network error and it shouldn't be leader anymore because it thinks the term is old. The term is, by the way, always incremented whenever something calls an election, locally. But then propagating that is all about the RPCs and all that shit. So that's why it's kind of important to have all of that, to have that constantly synced up, right? Oh yeah, I was reading my scrap notes from 2A that I took yesterday. And that's how a single leader is elected because every server casts only one vote per term number. So that's what I mean by a term. Even if they disagree what the term is, the terms are all numbered. So per term number, every server casts one vote. Not only that, but in order for something to become a leader, it has to have a majority in a given term. So that should drop out of that. Maybe I should start writing down the relevant details somewhere else, but no, I want to flick through this first. So, we're storing state variables in the Raft struct, and we define a new struct to hold information for each log entry. That's a detail that didn't drop out of the paper as such, but it was in the hints, so okay. It's just telling me to implement some RPC structs, add a background go routine to start an election. This is the timeout routine, right? So it's interesting. What I'm trying to do now is all the things that I said should be going on in Raft that are relevant to task 2A, the leadership election and heartbeats only part so far. Those are all sort of present in the hints in the actual problem sheet, and I'm trying to sort of link them. So this bit corresponds to the timeout routine, which is this. That corresponds to that. Heartbeats, leader sends out empty append entries RPCs periodically. A handler for this RPC that resets the election timeout. The election timeout is the one and only timeout, this timeout here. There's only one timeout. So I do remember yesterday getting a bit confused as to what was meant by election timeout. Heartbeat timeout leads to a new leader election, leader stepping forwards. No timeout, no peer steps forward as new leader. Okay, having read through my notes, probably what I'm going to do is kind of like a grep, text filter this, not automatically but just manually, to pick out the stuff that will be relevant to part 2A. So to do that, I'm going to make a new section on this document where I'm going to say what's the name of the other one? Sketch, Raft sketch, brackets, filtered for 2A. Mine eye is getting stuck again because of my constant, persistent cold. So, Raft sketch, filtered for 2A, let's copy and paste some shit. Which of the bits of the sketch are actually relevant to what we're doing? Well, we're going to need both of the RPC outlines, that's for sure. Both of the RPCs are going to be used. Append entries with no data, the heartbeat version. And request vote, obviously. Conceptual processes, which of these do we care about? We don't care about the leader updating followers or the entire data process, the data phases. The fucking new line. How should I do that? Just rewrite this as SVC. SVC means service, yeah? Yeah, checks out. So this conceptual process is the one that we're implementing. Re-elections if follower doesn't receive append entries from leader. What I'm actually going to write that as is the entire timeout routine. Followers, timeout, meaning they call election, if no append entries RPCs received for a while. Yep, the technical detail is there is also a part of the timeout is, did I just issue a vote? If I did, I'm not going to call an election timeout, that timeout, which is a technical detail. But the most important really part of this is if nothing is being received. This only comes from the leader, and so if this is not being received, because the leader should always be sending these. If these are not being received, that strongly implies there is no longer a functioning leader. And so we are really, trying to only call an election if we need to, if we strongly suspect that there is no longer a leader. Okay, which of the state variables are we implementing today? Next index and match index are all about tracking the leader tracking data, what data the followers have. So these are not relevant to us for part 2a. On the other hand, we do need current term, we do need voted for. We're implementing the entire voting system. Don't need the log, and these also track locally the master's log. Sorry, not the master's log, the leader's log, but also any follower's log. These 5 are always present on any server, whether it's a leader or a follower, and these are the leader tracking the followers. But also, these are about data, these are about data, as is this, obviously. This is where the data is stored, but these 2 are the ones that are about elections, and this is used to check that the data is synchronized correctly. So these 2 are the variables that we care about today. Just to make sure I didn't drop any messages, no worries. So, yep, continuing on, pushing on. Followers timeouts. Yeah, these are the state variables that we will implement for the beginning, task 2a. And all of the doings. Always good to be kept smiling, I guess. Not too many. Not too, it's funny, like, Go is, kind of designed to mostly be about references, in the sense that you have channels, you pass channels around functions all the time, and you don't copy channels ever, because channels are like the things that are used to communicate between things. You don't copy those, you just use the same one. But you can always pass the channel by value, but that implicitly gets converted to the pointer, because I don't know, that's how it works. But generally speaking, data in general, most of your types get passed by value, and so you have to star them. If you're passing like a complicated object type thing, a struct, then you will want to pass the pointer usually. Whereas JavaScript, obviously, none of that. It just, I don't know how, I don't explicitly know how it works. I know how Python works. It passes references by value, whatever that means. Can't be bothered to describe it, but it does make sense once you get used to it. Makes it a slightly beginner unfriendly though. Okay, yeah, jumping through the doings, all the doings. The doings are the things that should be going on. These are not necessarily all concurrent with each other, but they are conceptually the kinds of bits of code that we are trying to bunch together into a cohesive whole. So which of these do we care about? Flushing data moves data from, if we look at data phase, it moves it from stuff that has been committed to the log, which is tracked by commit index, is applied to the service in the sense that there's a fixed channel that's specified by the Raft version MIT has provided that you send to in order to communicate with the service. So this is a general doing, because every server, whether it's a leader or a follower, if it thinks things have been committed, it keeps sending them out, applying them to the service, and so the service should be receiving from all the servers in Raft. It should be receiving the commands that Raft is supposed to be synchronizing, getting them from the client to the service as an intermediary in a safe manner. That's fault tolerant. Fault tolerance is really the point of all this redundancy. Still, I'm still not that clued up on what Raft is for, like practical uses of it. I'm Project 3 hype. This is only Project 2. But I'm happy enough to just drill it for its own sake, because I think it's a very elegant system. Yeah, what I will mention also briefly is the illustration of how Raft works. I went through this last night, but I think it's worth everyone taking a look at this if they can. The illustration. So it has a nice, memorable URL. thesecretlivesofdata.com/raft. And if you flick through this, it takes about 5 to 10 minutes, depending on how much you want to understand. Because I already understood most of it from the Figure 2 specification before I looked at this, but it kind of gives you a pretty good intuition on how it works. So I would very much recommend this, which I think I maybe should have looked at before I looked at Figure 2. It's a slightly more masochistic way of doing things, but alas. So that's The Secret Lives of Data. Pretty nice. Yeah, maybe I'll tweet about that later, actually. Twitter handle is the same as the Twitch handle. Because it is a really nice demo thing. Cool. Where was I? Looking at the doings. Yep, so my point is this is a data phase thing. It's about data getting transferred from log to service, and we're not implementing data at all for part 2a. So we don't need this. We do definitely need this though. Fundamental assertion. I keep abusing the word assertion. It doesn't really make sense. It's more things that we're trying to get to agreed among all of the servers in the cluster. Sorry, I'm not sure cluster is the right word because they're not workers trying to do stuff, but it's a group of peers. I don't know, peer cluster. So yeah, what did I say? General doing absolutely everything is always executing this. This is handling absolutely every RPC synchronizes terms for each RPC. If my term is old, I should be follower. Again, it's that character thing. Let me just whatever. What? Did I add like an... Oh yeah, see I copied in from the other document, so I have to resave it in Unicode. Because it's stupid. Yeah, no worries. If followers don't hear from a leader, then they can become a candidate. But for how long? So I'm guessing how long means how long do they have to not hear from a leader? Which is something I haven't cared about at all yet because I'm just going conceptually. There is a timeout. Cool. But like how long it actually is, let me see if I can find some information in the testing section. I think this is literally it. That was quick. Election timeouts in the range of 150 to 300 milliseconds. It's not quite the real world board system where like a timeout is probably a few days or something. But yeah, super fast. Like such a range only makes sense if the leader sends heartbeats considerably more often than once per 150. Yep. But the tester limits you to 10 per second for some reason. Oh, okay, so we will have to use an election timeout larger than the paper's 150 to 300. So real world is going to be something like 150 to 300. But we will be using something bigger, not too large, because then you may fail to elect a leader within 5 seconds. Well, 5 seconds is, in the real world, pretty slow, I think. But yeah, that checks out. So yeah, in the real world, it's that much. I don't know how much I'm going to do when I come to implement it. 10 heartbeats per second, let's say that we're trying to send every 200 milliseconds, and therefore a reasonable timeout is something along the lines of 600, I think, just intuitively. I don't know. Okay, thanks for the comments again, making it very entertaining actually having comments. So yeah, let's press ahead, copy in the other stuff that we're going to need to care about. So, yep, term sync. This obviously highly important, essential, bigly important. All about becoming a candidate if there is a timeout. So this is the entire timeout system. I've written it down as a process here. I'm happy to have that written down in 2 places. It's not a massive problem. The entire candidate cycle. As soon as it becomes a candidate, it starts an election, and the start election process does all this stuff. It kind of loops. I think it ends if it becomes a leader, if there's a majority. This can interrupt it at any point, i.e. something else has become leader, and if there is a timeout, it starts a new election. I think that's the interpretation of that, because it's been written slightly out of order, but this is from the original figure 2a. So the entire candidate doings section gets copied in, and leader doings. Okay, which of the leader bits do we care about? We don't care about, so like I said, there is a bit of something that a follower does that hasn't been mentioned here, which is it also increments commit index tracking the data, which I have not at all discussed in this sketch because it was kind of in the wrong place in figure 2 when I was going over it. Like it's in the back of my head. Do you know, I should just make a quick note actually, in case it stops being in the back of my head. Um, just say like check how commit index is incremented by followers. So this is how the leader does it, but how followers do it. Again, I don't want to spend time on this because not at all relevant to task 2a because there is no data. But which bits do we care about? Let's just copy those in. Why did I minimize? Keeping followers updated, that is again a data cycle thing. Client requests, very data cycle. There is no client requesting going on yet. So literally just the heartbeat section of the leader is what we are doing, these two. This is it. This is the full sketch, I think. All the stuff that we need to care about. Everyone is doing this. Follower is doing this. This is the candidacy cycle, and leader is doing this. And one state variable that we haven't discussed because it didn't turn up in the paper is the whole, am I a leader, a follower, or a candidate? Do I think I'm a leader, a follower, or a candidate? Which, as far as I understand, should be another state variable, but it wasn't written in the specification for some reason. But let me just write it down anyway. I'm going to probably implement that phase. So again, it was the illustration of Raft more than the paper on Raft, the figure 2. I haven't read the rest of the paper, I've only looked at figure 2. It was the illustration, the demo, that early on it says there are 3 phases, and those are leader, follower, or candidate. Whoops. What the? Chatty. I've barely used this app. I've really just been using it to get dings whenever a message happens. The election timeout is the amount of time a follower waits until becoming a candidate. Yep. The election timeout is randomized to be between 150 and 300 milliseconds. Yep, that's how it is. I do remember reading that somewhere in the something. I read that somewhere. I can't remember where. But yeah, 150 to 300, like we said, is going to be a bit looser in the lab implementation that we're doing, for the reason it said about the tester limiting the number of heartbeats for some reason. But the randomization, why is it randomized? Well, this is literally something I mentioned earlier. If too many things call an election at the same time, then you get split votes, re-elections, and if things just sync up, then there's going to be a delay. We need to basically choose a relevant follower as soon as possible. Any of them will do. A relevant one is one that, according to its peers, has the most up-to-date data. I think that's it. And literally the first one of those that calls an election and gets a majority vote, as in the majority of peers, are in contact with it and think it has up-to-date data, that gets elected. Which is why it's bad to have split votes and things, because we are not, it's not some meritocracy. We're trying to pick out literally the fastest one, the first one that we can that is going to work. And so that's why we randomize timeouts locally, in order to try to not get election cycles to sync up and get split votes. If there's a split vote, we do another election. It's not the end of the world, but it's as a performance thing, randomization. It's something that I didn't even occur to me what I might do in order to get that to work. I just thought, how do I stagger them? Like, do I use like a global variable that sort of specifies who does what? But then I was like, nah, distributed systems, global variable. The fuck you talking about, mate? So it's like, okay, I shouldn't have thought that. I'm sorry, but a randomization, that is the one. That's how you're going to do that. So no worries at all. Very nice system. Hay fever. Is that hay fever? Do we think this is hay fever? I do not know. It's not like there are any fucking plants outside, except for that one tree. Yeah, it probably is hay fever, to be honest. I'll just blow my nose quickly again. Gotta get the oxygen back as well. Cool. Yeah, no, that checks out. Thanks, by the way, for reminding me of the detail about the randomization and stuff. It's the exact time that I needed to read that, to be honest, to make sure I remembered it. So this is the Raft sketch. Whoops, sorry. This is the sketch of the 2A part of Raft. The leader is doing that candidate cycle. This is how. So you can see that the cycle is just there. There's only one thing that's really independent from the cycle, and this is the RPC synchronization. So the RPCs are. This is always happening. Whenever there's an RPC, we take that as an opportunity to synchronize terms. The term meaning which election in a line of elections do we think we are at, and that keeps getting incremented by whatever caused an election, and it tries to propagate the term via synchronizing every time there is a remote procedure call, a communication between any two servers. But these three things actually form a cycle. The leader is constantly doing this, and when it stops doing this, this happens, and then whenever this happens, this will be done by the relevant follower, turns into a candidate. And something gets elected leader, and it uses the fact that it's sending heartbeats so that any other follower that may or may not be a candidate gets converted to a follower because this starts to happen. This interrupts the candidate cycle. Where to go from here? Gonna be hard to implement split votes. Possibly. Split votes are this, effectively. No, I mean, for all I know, commenter could be someone who's done distributed systems, looking at me. So, you don't know, man, you weren't there when you're doing one of those, like, nightmare type projects. I mean, I used to see this in Churchill, of course, because I did a maths degree at Churchill College, Cambridge, and I'm now just learning Chomsky, kind of on the way to a job, hopefully. But the Chomskys, yeah, Churchill was really the best place in Cambridge to do Chomsky, and when we were freshers, like the Chomskys got drilled quite hard with work, and so someone would assign. The director of studies assigned them like this massive project that took most of them into like the early hours of the night. They're all sitting in the bar, and then the Komskis from the years above are just walking by, going, I remember when this happened to us. This is hard. This is easy. You're gonna get wrecked. That kind of stuff. It's just part of the ritual of learning, which is something fondly remember. Fondly because I wasn't doing that, but then again, maths was probably a lot harder. I mean, that course is just intensely difficult. I don't know how it compares to the US ones, but certainly in Cambridge law, it's like a 200-year-old heroic course. Not quite as heroic anymore, but they still have a lot of archaic traditions that the exams are basically a complete gamble. Um, and I got quite lucky to get a 2-1. Have to say, had very easy questions. Ritual of learning. Yes, yes. Don't know if streaming counts as within the ritual. That's something I just decided to do for shits and giggles. Um. Okay. What next? Do I look at the hints? There's so many hints. No, do you know what? I'm not gonna do that. The first thing I'm gonna do is look at the code. So not necessarily. I actually made earlier. I made a summary during actually the first session, Sesh 1. I made a summary or an index of all the functions that I'm supposed to edit. So here we have, struct for the objects and func for the functions, things that need to be edited, and ABC as in which task each one is getting edited in, because it actually says in the comments, your code here brackets part A, part B. So I went through and abridged this. Should I do a filter reorder? Not necessarily a filter. I want to keep it in the original order, but I will. Sorry, not necessarily a reorder. I want to keep it in the original order, but I want to just copy out the ones that have A in them, just to look at what's important here. What gets implemented where? You're asking me. You're asking me. This is going to contain state variables. I know that much. Get states starts and get states. I know that looking at the interface, that's another document which I made earlier. This is kind of what it's like, what the Raft project is like, um, what Raft is going to be like from the perspective of the service that uses it. And so I said here, get state is really just like start, but without actually doing anything. It literally just returns some information, and so start is going to do that and then do some other stuff. This obviously is not relevant for part A because it's a data thing. Returns the term and is leader without running start. These are all, I'm still kind of confused. I think these are all run by individual servers, or at least they are methods. Well, yeah, I mean, these are methods within the Raft object, and the Raft object is what is run by every server. So get state is going to just provide access to a couple of state variables, namely, but which one is it? The isLeader and the term. So isLeader is going to be the phase that I said here, and the current term is just this. So those two are going to be exposed in those methods. Maybe I can just implement those straight off the bat, but I'm not sure I want to without getting first a better idea of what's going on. I'm still very much trepidating around actually touching the code. Where is the damn code? It's here. Raft. I have that classic Visual Studio scroll bug, which is fixed by restoring and maximizing. This? I'm not going to need to use the terminal for a long time. But yeah. Yeah, I mean, there are a lot of fuck ton of comments as well. So I guess it's not going to end up being too difficult because there are so many hints. But the hints are all over the place. So we have we have information in the comments here, and then we have just a crap ton of hints here as well. Shall we try to? Dear. Look at all this information. MapReduce was so much easier than this. So much less stuff to keep track of. But I guess that's why it's the introductory projects. I'm hoping honestly that projects 3 and 4 are going to get easier, just because there's in the sense that there's less to keep track of. This is going the whole hog with like a full-on protocol, whereas project 3 is like implements the key value service that uses that uses Raft for its underlying consensus, and part 4 is shards of that key value service. Sharding meaning splitting, of course, so that different key values end up on different servers, but there's also still some sort of redundancy going on. So yeah, this stuff, I mean, this is my clearest idea of what's going on. This is what I want to hold on to. Term sync, candidacy timeouts, and the full election process, and then the leader sending heartbeats. This is the heartbeat section. This is the leader election section, and this is just a kind of resilient thing that continues to happen every time there's an RPC. I'm still not clear on how RPCs are implemented in the code. Just looking at it, there are bits of code that definitely correspond to them. Send request vote. Oh yeah, request vote is an RPC. It's the voting RPC. There's another RPC. What's it called? Applied. The data RPC. What was its name again? It's in the Raft sketch at the top. Append entries. Okay, append entries doesn't seem to have its own function. I guess I might have to implement my own one. But look at all this. Let's see if we can break this down slightly. Okay, maybe I'll. This is pre-implemented, but it's still very much a part of section A, as is apply message is not. Apply message is the data phase sending to the service, the end of the data phase. The data cycle, sorry. It's not a cycle, it's more a line, data line, end of the data line. Yeah. So this stuff, request vote args, request vote reply, request votes, send request votes. Let me just reorder that slightly. So Raft, this contains state variables. Get state accesses state vars. Get state accesses state variables immediately because it's on the native computer, so on the server on which it's run, it can just access its own variables, no problem. This is like the trivial bit of the implementation. Make, you think I remember what make does. It sets up an entire Raft instance, so I think this is not worth worrying about yet. But then, yeah, this stuff. So we have two functions, send request vote and request votes. Request vote is actually the receiver, I think. Let me just check. Request vote RPC handler. So it handles it and then replies with another RPC. But then again, the reply should also be handled. Should watch out. I mean, if you remember the simple fact that we have every RPC must synchronize terms, if you remember that. I mean, that means that whenever request vote is an example of an RPC, whenever a request vote is done, the thing that receives the request runs the request vote handler, but then it replies, and there should be a reply handler, shouldn't there? No, not necessarily. The reply handler, I think, is part of send request vote because send request vote is run in a concurrent coroutine, a go routine, and that blocks until there is a reply, and so there's no need to write its own reply handler because the code blocks there. And so when the reply happens, that routine picks up, and so we can just sequentially handle the reply. So that makes sense. Okay, so basically send request vote is the RPC interface function on the sender side. Request vote is the same one on the receiver side. Where do I want to write that down? Here is fine. Sender RPC handler receiver RPC handler, but both of these only correspond to request vote in particular. And request vote args is the struct of sender RPC data, and the reply is the receiver RPC data. Okay, yeah, we have in the figure 2 breakdown if the entire sketch of the whole damn piece of shit thing. That has it goes into detail about the structures of the arguments and the reply, and so it's fairly clear that we said state variables are stored here. These two things store the RPC variables that are defined in the documents. So I'll just show you what I mean by that quickly by opening it up in fucking Edge. Arguments. Results is just what comes back, what is returned, because RPC is in Go. That's a synchronous thing. It's run in separate routines, and so it just returns the results. But these are the arguments that are sent in, and for request vote in particular, this is what they look like. Well, though actually no, what I said isn't true because oh no, it is no, sorry, it is true, but it's never mind. I'm getting hung up on details that will be completely elucidated when writing down the implementation. But basically, information that gets sent that way, information that gets sent back, is stored in the structs, the objects. And yeah, it doesn't matter, but I think the received information is returned and the sent information is handled by a separate routine that gets triggered whenever a receipt takes place. And then, yeah, receiver implementation gives details about how to implement the receive side, whereas the sender doesn't necessarily. But then again, for the purposes of Project 2A, the sender is the thing that's already been implemented, so I guess it doesn't do anything, really. Should we take a look at the code quickly? Send request vote. Not matching case. Leave me alone. Oh, okay, yeah, it's just this stuff. It's literally one line of code. RF Raft dot peers. So it knows our implementation of Raft has a completely fixed, never changing set of peers of other servers. The server cluster is always the same. It's just that some of them fail and come back to life every now and again. But the peers doesn't change. We always know what all the servers are. Each one. No, sorry, not each one. We're peers at the server index, which is this. This means self. No, it doesn't. Sorry, server is I think server is the destination of the request vote. Server, args, and reply. These are the three arguments in the signature of send request vote. Server is where send request vote is going. Args is the argument, and reply is a request vote reply type that we initialize as a location in memory to save the reply. That's the star there, meaning we pass a pointer to where we want the information to be saved, to the reply information. And then the sender doesn't do much, it just calls, so this is the entire RPC routine, a request vote with args and reply, when that happens, it returns whether or not the request succeeded. But also at this point, the thing will have replied, so I imagine this is where we would put the stuff to handle the reply, namely the synchronization of terms code. Which is kind of dodgy to me looking at this, because it doesn't say you should edit this, but potentially we will be editing it. Yeah, there is such a crap ton of comments, honestly. Okay, but that's really it. That's the request vote args. The heartbeats is another thing, but I think like it just doesn't even give any structures for the heartbeats. But did it say we had to implement that in one of the hints that I wrote down? Yeah, up here. Define new struct to hold info per log entry. That could be structs for append entries RPCs, which are not. I don't know. But because all of these functions are already there, I think I am going to first implement the leader election side rather than the heartbeats, just because I have the outline to work from. And I think I am going to end up writing, a copy of all of these functions for the other RPC, which is append entries. Okay, fine. This is, initialization, and this is about the state variables, so none of the other code even happens anywhere. It's just all bundled in these functions. But you have a bit of flexibility for how to do the implementation, to be fair. So I could end up making new functions, no problem. Okay, now that I've done that, I'm going to look at the hints. So that I can just at least try to sketch what is going where before I start trying to implement shit. So yeah, I am gonna, after all, try to read through the hints. And try not only, it's not even reading through the hints, it's just like assigning hints to different parts. So I'm gonna let's okay, take 2A, the 2A document here. Reshuffle. Which has a bunch of hints in it. This is the sketch of processes. What I'm gonna do is try to split it up and put the hints under the bits that they are relevant to. So I'm gonna retitle all these sections. This is gonna be term sync, RPC term sync, which is a I think a fairly fundamental thing that should be happening in every RPC, the synchronization. This is candidacy timeout. Let's delete redundant pieces of information. This is election. Follower candidacy timeouts. General RPC term sync. So only followers do candidacy timeouts. Only candidates call elections. And leader sends heartbeats. Right, so just a bit of reshuffling here. Whoa, okay. Start election. Yeah, I may as well just write it down this way. Okay. These are basically the four atomic sections, and I have bundled the initialization things in with the things because it's kind of like, I have this function that loops. Both of these keep looping, and it's just the first instance of the loop. It doesn't really require a conceptual separation of ideas. So I'm absolutely down with that. No problems. All right, this is literally it. So we have all this stuff, and this I'm gonna delete. I don't think it's necessary anymore. So I'm gonna dump as many hints as possible. Under all of these sections, and then try to process them into pseudocode. That's going to be my approach to getting an idea of what's going on here. So I'm going to try to minimize the amount of time I'm implementing and debugging by reasoning through the theory as much as I can. I think for this in particular, because it's not atomic like MapReduce was, it was kind of step by step. I think it's important to do it that way. I think it'll be more efficient in the long run. Or even if it's not more efficient, it'll just be less stressful and more enjoyable. I think I'll end up understanding it better. So I have to say, programming category, perhaps not. This is more like just studying or something. So, people telling me yesterday I should just recategorize this as IRL, so I can be in with the weebs and the cosplayers and the like women selling sex or whatever in the such a bad way of putting it in the idiot no, as in what do I mean by selling sex? I mean like selling sexuality, posing and that kind of thing rather than anything else, prostitution. Anyway, yeah, fucking what? Okay, check it. Hints. We're flicking through all the hints now. I'm gonna ignore all of this stuff and just reprocess it, just for simplicity. Any state you need goes to the Raft struct. You'll also need to define a struct to hold information about each log entry, which is funny because there are no log entries in part 2a. I don't know why they've mentioned that here. Your code should follow figure 2, yeah, whatever. Uh, so yeah, I'm just going to write in to sort of put it down here actually, to just sort of specify where in the code I think this should go. Raft struct. Ignore the line about log entries. Heartbeats, obviously we do not need to store information about those. Fill in request vote args and request vote reply. That's what it's telling me to do first. But also request reply args, right? What is that called? It's not called what I said it's called. It's called something else. Sorry, it's in the index. Oh yeah, request vote reply. No, it's saying fill in request vote args and request vote reply struct. Oh, okay. So it's telling me to first so this is what I'm also gonna do, just to make things, a complete piss take. I am going to. Oh shit! Hang on. Sorry, my plastic box that's keeping the grill up slid out. Okay, I've put it back. Okay. Yeah, this is what I'm gonna do. I'm gonna try to do basically a cookbook based on MIT's hints. I'm gonna try to assemble a step-by-step process using the hints, which potentially this makes it easier than it should be. But I'm not gonna. I'm gonna use all the hints available. I'm not gonna artificially block myself, even if I'm gonna use their judgment for how difficult it should be. Even if I end up learning less than I could have, because I could have made it harder for myself and therefore learned a bit about, figuring out in what order to implement things. That's an important thing when you have a big software project. But for the purposes of this. If the hints are there, fuck it, I'm using them. M9. So yeah, number 1, add state vars to Raft struct. Add vars to request vote struct. Send and receive. Right, modify make to create a background Go routine that will kick off leader election periodically by sending out request vote RPCs when it hasn't heard from another peer for a while. Oh, okay, so it's telling me quite explicitly, it's saying implement candidacy timeout in make, right? It's pretty explicitly said that. This way a peer will learn who is the leader, if there's already a leader, or become leader itself, yeah, whatever. Implement request votes RPC handler so that servers will... Oh, okay, implement the handler so that the servers will vote for one another. Okay, yeah, careful here. So, yeah, this is not just candidacy timeout, this is candidacy timeout and call election. Whereas the response is implement voting, basically. Implement, yeah, this line. Implement the request vote RPC handler so that servers will vote for one another. You know, servers voting is not something I've discussed at all yet, but it's specified in the outline in Figure 2 of the Raft paper. The big outline. I mean, I keep calling it Figure 2. I can't think of a better name for it, but this thing, it is Figure 2 in the Raft academic paper. But this is just an outline of everything, and so I haven't actually covered how voting is done, how votes are sent, by how votes are replied with. But that's actually basically just here. It says here literally reply false if this happens and reply true if this happens. Like that's where I at least know where all the information is, so I'm not going to have any problem with that. Implement voting. In the obvious place, request vote RPC handler. Receiver. So, you know, there are send and receive structs, and there's also a sender and receiver function. And those 4 things make up an RPC implementation effectively. And I think I'm going to have to make all of them for append entries as well, which is cool. Absolutely fine with that. Okay. It'll probably say in the hints exactly what I need to do. To implement heartbeats, define and append entries RPC struct. This is what I mean. Though you may not need all the arguments yet, and have the leaders send them out periodically. Write and append entries RPC handler that resets the election timeout so that other servers don't step forward as leaders when one has already been elected. Sorry, where am I? 5. Add structs funcs for apply entries. Heartbeat first. Heartbeat first, what I mean is because heartbeat is an empty apply entries and it does not even really require a response, I'm not going to need the structs specifying data at all. I can just get away with implementing the functions, I think, but it doesn't matter. Like, all of it will have to be done eventually anyway. What else? Other servers don't step forward as leaders when one has already been elected. Yeah, write an append entries RPC handler method that resets the election. Have the leader send them out periodically. Doesn't say which function to put that in, but yeah, implement leader sending periodic heartbeats. Maybe via a new function. May not need all the arguments yet. Have the leader send them out periodically. Write an append entries RPC handler method that resets the election timeouts. So that, obvious reasons, other servers don't step forward as leaders when one has already been elected. That. Continuing on. Make sure the election timeouts in different peers don't always fire at the same time, or else all peers will vote only for themselves and no one will become the leader. That's the whole split vote situation. But also, you see it says here you may find goes around useful. Yes. I'm pretty sure those are connected to each other. I'm just going to write that down as a note under the... Yeah, no, stuff that I haven't written down here yet. I'll add it as a note here. Desync them using rand package. That's all we need to know, really. The tester requires that the leader send heartbeat RPCs no more than 10 times per second. Okay? The tester requires your Raft to elect a new leader within 5 seconds of the failure of the old leader, if a majority of peers can still communicate. Remember, however, that leader election may require multiple rounds in case of a split vote, which can happen if packets are lost or if candidates unluckily choose the same random back-off times. You must pick election timeouts and thus heartbeat intervals that are short enough that it's very likely that an election will complete in less than 5 seconds, even if it requires multiple rounds, but not more than 10 per second. Even if it requires multiple rounds, but it doesn't say how many multiple rounds. I would say it should be vanishingly unlikely that it goes beyond 4 rounds. So just try to get 1 round to happen per second. That would be my personal target. Aim for 1 election round per sec. Because the full election has to be less than 5 secs. Paper section 5.2 mentions election timeouts in the range of 150 to 300 milliseconds. Shout out the commenter for reminding me. Such a range only makes sense if the leader sends heartbeats considerably more often than once per 150 milliseconds. Because the test limits you to 10 heartbeats per second, so it's going to be about literally once than that, you will have to use an election timeout larger than the paper's 150 to 300 milliseconds, but not too large because then you may fail to elect a leader. Not too large because then you may fail to elect a leader within 5 seconds. They've said nothing new there. That's just working within this constraint at the same time as this constraint. This one. Sorry, this one. This constraint vs this constraint. I'm going to write limit just to make it clear that that's implemented by the tester. You may find goes rand useful. Yep, I covered that. You'll need to write code that takes actions periodically or after delays in time. The easiest way to do this is to create a go routine with a loop that calls time sleep, which blocks the loop. The hard way, the hard way is to use goes time.timer or time ticker, which are difficult to use correctly. Understandable. There's no real reason to go beyond using sleep, because sleep is not guaranteed to be accurate timing wise, but it is guaranteed to work more or less reliably within approximately the times you want, because logically sleep is all about sorry, let me just check the liveness. The liveness is still up. Camera, feed, and microphone. Yeah. Oh, it's only 1:35 so far. Oh yeah, because it started at 12:30. Yeah, logically. Um, logically, the time sleep is all about blocking and waiting for a bit, and then continuing. So it's just like a single routine that keeps going. Whereas time timer, time ticker, those are, well, why are they difficult to use correctly? Because they involve juggling things at the same time, not necessarily splitting Go routines. Definitely not, because Go routines are completely independent of each other. So this is about synchronization, whereas we're trying to achieve synchronization by coordinating separate routines, Go routines, rather than some top down nonsense that I think is unlikely to work properly. So time.sleep is going to be used for delays. Oh, fuck, that jumped up to 5,000 kilobits per second. Should not be happening, but whatever. Oh yeah, I said I would consider switching to CBR, but I think because so little happens on the screen is so stable, I think we will actually get better performance using VBR, believe it or not. In a video game, you would definitely use CBR. And that's just a comment that I read on Reddit or something that got me thinking that way. That's totally chill as well. So yeah, let's write it here because it's earlier on. Periodicity via time.sleep, time package sleep routine, rather than timer and ticker. If you are puzzled about locking, I still don't really know how locking comes into things, but I guess I do, because the structs are accessed by lots of things at the same time, and I think I will have some intuition. I will be able to see it coming when locks are necessary. So, puzzled about locking, you may find this advice helpful, the whole locking advice. I have clicked onto that before. Okay, I know that exists. I can remember that. If your code has trouble passing the test, read the paper's figure 2 again. The full logic for leader election is spread over multiple parts of the figure. That's basically what I've done. Yep, a good way to debug is print statements when a peer sends or receives a message, and collect the output in a file via the arrow out. Yes, okay. Then by studying the trace of messages and out, you can identify where your implementation deviates from the desired protocol. Kind of, yeah, the way I debugged my bots back in the day, Pokemon Go bots, which also used quite a lot of asynchronous timing type stuff. The log was just the one that was so useful. You might find dprintf useful for the entire debugging shit. You may or may not use that. Probably not. It's probably more effort than it's worth. And yeah, Go RPC sends only struct. The fuck. Sends only struct fields whose names start with capital letters. Let me switch switch around this fucking tray. So I'm actually using a don't know if I've ever shown anyone this, but I'm using a book about dinosaurs as my tray. It's the classic dinosaur hunts, the Great Dinosaur Search. Lots of fun as a kid just finding all the dinosaurs. Okay, whoa. So, let me just position that bloody nuisance. Maybe I should blue tack it to the laptop. Straighten up a bit as well. Yeah, check it. Camera. yeah, just gotta have that ruffled aesthetic. Uh, apparently that works for me and shit. So yeah. Okay. Go RPC sends only struct fields whose names start with capital letters. Subs. Okay. Everything in the struct has to be capitalized. Substructures, but it gives warnings, and it says don't ignore the warnings. That's completely chill. I definitely won't. Substructures must also have capitalized field names. Fields of log records in an array. All data, all literally anything that's sent and received, capitalized field names. You should check your code with the race detector. Okay. Lots of hints. The first few are like a cookbook. I would say up to here, the first 5 hints are the first 4 hints, in fact, are the cookbook, and then there are lots of useful details to watch out for. Okay, that has been read through. That has been summarized. Is it time to begin? Begin trying to implement stuff. Does this cover everything, by the way? It's interesting because this does not cover RPC term sync at all. So I think possibly this is not required for project 2A and will be done in later ones. Because I'm seeing no reference to it in the hints. On the other hand, candidacy timeout and call election and the heartbeat sending, those are all implemented, as are the other bits and pieces that I haven't covered, which are all compartmentalized under how to handle responses to RPCs. The receiver implementation in figure 2, that stuff. Which, honestly, I would have probably covered the same way I've covered all the other stuff. I just ran out of energy yesterday, literally. Really went far too hard. So I'm not going to start the actual implementation today. I will just sketch everything. I'm not done sketching yet because I have I'm not necessarily going to read all the comments, but I'm going to just try to get an overview of which comments are about what and how that fits into everything that I'm doing. And then I will and then I will just try implementing, one step at a time to try to clear project 2A in the next stream 4. I think this is a pretty reasonable sketch phase, even though I didn't really think of it as a sketch phase as I was starting out, and so I didn't ping the log as I usually do, but I'll sort that out later, no worries. Add state vars to Raft struct and add all the vars to request vote. That's going to be simple enough. Candidacy timeout and election call, the entire election routine. Implement voting in request vote receiver. The eyes. Add, the outline stuff for apply entries, the heartbeats, and then implement the leader sending heartbeats and timeout resets. So this is the heartbeat phase, and this is the election. Those are the two things we're implementing. It's telling me to go for, reading the hints in order, it's saying go for election before heartbeats, which I'm happy to do. As well as the first two, which are just adding in generic structs and things. Okay, how does that relate to the index of things that are getting edited? Well, basically, this will be done within the state vars section. So yeah, let's cut it into this document, right? I know both of these come under the general state var stuff, right? That goes there, and then add vars to request vote structs. That goes there. Then, yep, make just a bit of formatting to keep my thoughts in order. Make is edited there, and implement voting in request vote receiver is not a part of. Oh yeah, no, here it is. Sorry, got confused. So send request vote is not going to need to be edited because we're not implementing RPC term sync yet. Okay, in the future I think we will need to implement that, and that may require editing it, but for the time being we're going to do without the synchronization stuff. It's interesting going without the synchronization. At least I know that it's there, it's in the specification, and I think it's important personally. But I know that I won't have implemented it after all this stuff, and so it's like a reliability change that I could implement if I wanted to. Add line breaks, make it all clearer. And then the heartbeat phase, I actually have to define new structs for, apply entries. Implement the lead ascending heartbeats. I'm not sure where that's going to be implemented. What do we think is the most logical place to implement that? Run a routine at the point where the leader is elected. So it's going to be at the end of. It's in make. Make is the thing that is running the timeout and the entire election. So in make, we're probably going to send off, put in the code that triggers a separate routine, put it in another function that runs heartbeats. So I think I'm going to add a heartbeats function to the code. Don't forget the stuff that's in the index, all this stuff. I think that's far from all the stuff we're going to need. We're going to be defining our very own functions, I think. And one of those will be the heartbeat function. There's definitely going to be a separate heartbeat function sending apply entries RPCs. There will also be a separate data function, and whichever one of those happens is the thing that resets. Receiving apply entries in general resets election timeout. Oh yeah, and this is what I mean. So it goes in the apply entry handler, entries handler. So here I'm just going to make a note saying, just adding in the names of the things. So apply entries, send apply entries, and apply entries the handler. And down here I'm saying heartbeat func triggered in go routine in make. And the election timeout resets, it says here it goes in the apply entries handler, which is called apply entries. I'm not happy with how these have been named, but I want to stick to the convention. So the convention is request vote args, request vote reply for the struct, and send request vote and request vote for the functions. Right? I think it's fair enough that the receiver function has the name of the entire RPC because there's a lot of detail in the paper about receiver implementation for each RPC. Not much about sender implementation at all. I think the sender only needs to do the RPC term sync. I don't think it needs to do anything else. And yeah, arguments and results. This is args and this is reply. This is args and this is reply. Right, so I think the convention isn't terrible, although I would have called it something else, definitely. I would have called it request vote sender, request vote receiver, request votes, send args, request vote, receive args, something along those lines. Or reply args, maybe. This is totally fine as well. So this is a no edit. Okay. So I'm gonna, just delete all that as if I hadn't edited it at all. Totally fine with that. Yep. So we know where everything is getting implemented more or less. We have a full sketch here. Okay, and the only thing that's left is possibly to read the comments. Although maybe I'm just gonna not do that and read the comments as I go, because I've managed to. The whole point of this sketching process is I've managed to decompose everything so that I know what I'm editing for each step, and I can jump in and find out the details in the comments of each thing that I'm supposed to be editing. So I'll give you an example. Say I want to implement the candidacy timeout in make. Make is the only thing where I'm really doing that, other than triggering the heartbeat as well. So I scroll to make. Service or tester wants to create a Raft server. The ports of all the Raft servers are in peers. This server's port is that. All the server's peers arrays have the same order. Persister is a place for the server to save its persistent state. Edit that later. Initially holds most recent saved state, if any. Totally not relevant for part A. Apply channel is where the things are going. Make must return quickly, so it should start go routines. Oh, it doesn't even contain any information about any extra hints. Okay, this is, and that's what I mean. So I'll read these in when necessary, as part of the actual implementation. So yeah, no, do you know what? I'm happy to cut it off there and leave it until I start doing. Let me just declutter everything and make sure everything is clean. While I have a few moments, because I may as well go the full 2 hours again, because I'm going to take a break for a day and a half. What I might do is just quickly to my sketch of Raft, my sketch here, I might just add in the stuff that I had not added in yet, because it's in because it was bundled in figure to the full outline in the request vote RPC section. Okay, that's totally fine. So let's just flick through the receiver implementations. It's not like they're particularly long. Okay, so request vote. Whatever receives a request vote. There is a logical distinction here. I don't want to bundle all that information under the leader doings, follower doings, candidate doings, because all of them are in response to RPCs, whereas none of these are in response to RPCs. All of these are just stuff that is happening all the time anyway. Committing to log is happening. Commit index being incremented by followers, even that is triggered by an RPC always. Keeping followers updated, on the other hand, everything I've written here is self-initiated. The phase change, the still alive, all that stuff. So there is a bit of a conceptual distinction between the two. So I am going to put the information under the RPC outlines. I will do that. RPCCH, I was saying that was kind of like another RPC, but not really, because it's like the so apply CH is kind of like what I expect would be an RPC in the real world, but it's another thing which is about sending the final answer. All the peers send their interpretation of what should be applied to the state machine, the service, at the end, through apply channel. Again, I'm just gonna delete that. don't feel like it's necessary to, because it's important, but it's also covered by the interface section here, and so I'm happy to just leave it there because that's not really part of the function as much. We don't handle those RPCs within Raft at all. Instead, we just send it there and see what happens, I guess. But these are actually properly handled, and so they are part of the full system. So what I'm going to do is just make these into separate sections. And put in handlers. And I'm just going to describe the handler. So the handler is the thing at the other end of the arrow. So there's certain followers or the heartbeat tool, but all of them are followers. So followers are handling append entries, and voters are handling. Voters are literally everyone is handling request votes. So it's pretty simple. Request vote is literally just reply with vote. Close to the end of the stream here, so I'll sort my eyes out after after that's done. Voted for is null or candidate ID. Reply with votes. False if term is less than current term, meaning the candidate's term is out of date, which is also automatically implemented on the candidate side as a become follower. So that's self-consistent. True if well, in fact, I'll just do a true if and only if. True if and only if true if and only if candidate term not out of date, candidate log extends, voter log, and voted for null or candidate. So the point is that it's only going to ever vote for one thing per term, and if voted for is null or candidate, then it is voting for that one. It's decided. In the case of candidate, it's already voted for the candidate. It's decided to stick with it. And null means it hasn't voted at all in that term, and so at that point decides with candidate and then sticks with it. So this is all totally obvious. And I'm also going to do the same thing for append entries RPC. I say totally obvious. It's just, I'm not going to continually re-explain things because it's a very complicated system. You can only look at one part at a time, and so I don't want to continually keep covering everything over and over. But this is exactly what we said how voting works last time. The three conditions for voting. This is part of a separate thing, namely the term sync thing. Namely, if the term is out of date on something, it becomes a follower immediately, and therefore this will vote false for it as well. That's completely consistent. And this is saying, okay, if the candidate's log is an extension of the voters log, then the voter thinks the candidate is up to date on the data. And this is just so it doesn't vote for various things. The voter chose the candidate and will stick with the candidate for the rest of that term. So okay, I did manage to kind of re-explain it there, not too badly. Okay, so receiver implementation on the append entries RPC. I should say arguments and results. Term and candidate ID are things that are always in every RPC. Term and candidate ID is sent out and term is replied. Reason being, this identifies the sender, and the term synchronization requires a term to be sent and a term to be received. Everything else is dependent on the RPC itself. So last log index, last log term, prev log index, term entries, leader commit. As far as the reply is concerned, that's the most important thing perhaps. Vote granted. Did it do a vote for the request vote reply? That gets stored in vote granted. So I can just label it here that's what vote granted is. In this case, the reply is success. In the case of an append entries, true if follower contained entry matching prevlog index and prevlog term. Those are details about the data system which we mostly spoke about last time. I'm not sure if I want to involve myself in those details again or just leave it until we implement data. That's what I'm going to do. I'm going to leave it until we implement data. To be confirmed. Task 2A does not involve implementing data. Even though I've spent a lot of time reading about data yesterday, that's not going to be useful for task 2A at all. So if I'd known in advance, I guess I could have tried to figure it out, but I mean, it would have been more optimal to read about that stuff after I'd done task 2A, but it's not incredibly important, I don't think. The append entries RPC handler is not needed for heartbeats. Although we will implement a handler regardless, it will just do not much. It says here, doesn't it? In part 2A. So the apply entry handler. Oh, here it is. It actually, no, it does the election timeout reset. Oh, sorry, so I was wrong about that, sorry. Okay, let's pick up that bit. It's definitely here. Is it not? Reply false if term less than current term, that's the term sync. Reply false if log doesn't contain an entry at the previous log and index, the thing that it thinks it should be updating with, so that's a failure. Details about data doesn't matter, this is a data conflict. Delete all the stuff that was figured out to be conflicting and then return false again, probably. Append any new entries and set the commit index. This does not talk at all about resetting the election, but that should also be in append entries receiver. So surprisingly, they haven't actually at all mentioned that. They might have just forgotten about it. But I'm pretty convinced that even though it's to do with the election and not the data, this is all data related, except this, which is the general synchronization thing, number 1. But 2, 3, 4, and 5 are all data related. There should, I think, be another one just saying reset the election timeouts. So let me just add that in here. Okay? But I mean, reset election timeout is going to happen for any append entries RPC in the handler, so that's, I think, important. But like I said, again, dealing with the details of the data, not necessary now because that's to be implemented later. No need for it. That's it. that is it. This I no longer need. I've explained it better. But yeah, state variable, of course, is going to be. I'm gonna add that back in. Phase. Who am I? Leader, follower, candidates. Okay. That's it. So, yep, conceptual processes, the data phase, and the election phase. The election cycle and the data cycle, I would call those the two big cycles that exist. And the election cycle keeps getting deferred as long as the data cycle is functioning correctly, which all depends on the leader staying in touch. Yep, everything else is just there in the information. I think I'll read the misc notes again because that's important. All RPC, as in things to just keep in mind. That was the entire point of this. All RPCs synchronize terms regardless of ulterior purpose. That's what I mean by term sync. Maybe I'm putting too much emphasis on term sync, but to me it just feels very important. It's the whole keeping things up to date. Where did I write down term sync? In the general doings, term sync, here it is. I become leader if elected, I become follower if my term is out of date. There are other reasons one can become a follower though. You become a follower also if you receive, or if I receive append entries at any point. So become follower should really be a part of append entries, I think. If anything receives append entries, it becomes a follower. I believe that is totally legitimate. So I'm going to put that in the handler here. Data handling TBC. So I've isolated that bit. That's something I'll look at later. Okay. Current term is stable if leader is successfully heart beating. Yep. Term only gets increased if there is a election triggered, and that only happens if a timeout happens, and if the heart beating is happening, there will be no timeouts anyway. Except perhaps in something that got disconnected from the network, but then that doesn't communicate and doesn't matter as such. Yeah, okay. Voter votes for one server per term, caches it's in voted for. Happy with that. Okay, that's it. That's all I have to do, and I am literally prepared, fully prepared, I think, to jump into the plan here. To run the cookbook and try to make sure I've covered all of this, except perhaps this, which I don't think is necessary. And that's it. Implementation starts tomorrow. Implementation, continual sketching and iteration, but basically trying to work through the cookbook and implement all those things one and after the other, and test and probably implement all of them and then do a debug. I'm not sure. But yeah, that's going to be all part of the do phase, running through that, using the notes, and doing implementation. Happy to leave that to the do phase and say this is the sketch phase. I think that's a logical subdivision. But yeah, cool. As far as continuing the stream is concerned, the next one will be at 10 on Sunday the 10th at 9 p.m. and I'm gonna work through the cookbook one at a time. That's it. To hopefully finish task 2A, because I have everything broken down, I think, and more or less understood. So again, another day passed. I didn't manage to actually do any coding, but I basically condensed all the information, so I'm pretty happy about that. There was a new... No need to update the fucking index file. Let me just... yeah. Who knows? Truly, who knows what has happened here? That is some like major text trouble shit. Wow. But never mind, this is just some text scrap, so I'm happy to just commit it as is. Okay. Ready to do 2A. And that's all. That's all for today, folks. I'm just going to run down the stream. It'll probably end in a couple of minutes. Yeah, chill. Okay. Like I said, next session 4, Rafto session 4, happening at tomorrow, Sunday at 9 p.m. and I'm just going to do 2A. I've made the cookbook. I'm going to follow all the steps, try to implement them, and then get on to testing and hope that it works out. Reading the comments in the source as I go for the implementation. Chill. Not bad. Feeling down, feeling up to it, and we'll see how it goes. And also, yeah, very much pleased to have had a bit of chat with someone today about doing an implementation of about implementing Raft, and just a bit of engagement, a bit of chat, a bit of bollocks, a bit of chatting shit. So what streaming's all about. When you have so few commenters, then you can just engage with all of them whenever, which is pretty cool. Obviously, if you're streaming, you can just about maybe read the influx of comments that's coming through, anyone's seen a live stream, particularly of a world record speedrun, when the chat just explodes, and even when it hasn't exploded, you're concentrating on the speedrun. Time is of the essence, and so you can't be there to answer all the questions. But it's all chill. It is possible to do it now this way. It's made it kind of interesting, kind of entertaining. So thanks for that. That's it. 9 p.m. tomorrow. Back. We back.